Hi, welcome to this video. If you are new to this channel, I encourage you to subscribe, and for those who are not first timers here, thank you for coming back. Today we are still looking at the Shem-Prashad LeetCode series, and we are currently on the 21st algorithm, which is the same 3 algorithm. So let's get to it now. So we have the algorithm here, and it says that given the roots of two binary trees P and Q, we are to write a function to check if they are the same or not. We are also told that two binary trees are considered to be the same if they are structurally identical and the nodes have the same value. So for example, here we have 1, both of them have 1 at the root node, and on the left node we have 2, on the right node it has 3. So this is identical, so we are to return true. So that's why we see here in the output return true. In this one, on the root node both of them have 1, so it's the same there, but the 2 is on the left node here, while 2 is on the right node here, so they are structurally not the same because this is on the left node while this is on the right node. Here we see that we have the same root node. On the right we have 2, but on the right here we have 1, while on the left here on the right here we have 1, while on the right here we have 2. So it means that they are also not structurally the same, so this is a false. All right, so we are told that the number of nodes in both trees is in the range of 0 to 100. So it's possible we have an empty tree with no node, or with up to 100 nodes within that tree. Okay, and the value is between this and 10,000, negative 10,000 to positive 10,000. Okay, so this is what we have. So let's get to our board and see how we can come up with a solution for this. Let's just talk about this. So here we will have our trees. So let's say we have one node here, another. So this is 1, this is 2, this is 3, and we have this, and then we have this here also, 1, 2, 3. So how does it know that these are structurally the same? Is that if we start from the root node, when we check the root node, we see that both of them have the same value. So this is fine. When we get to, for the root node, if we go to the left and we go to the left of this other root node, we see that both of them also have 2. So that checks out too. And then when we go to the right node, that is this and this, for these two, we see that they both have the same node. So this is, and that's how we know that this means it's fine. But if, for example, we checked here and this had another node 4, this definitely, when we try to check it with this definitely doesn't have a root node. So we know that definitely something is off. I mean, this doesn't have a child node here, so we know that definitely there is nothing to compare with, and it's done. So that's how we could do this. So I think basically this is what the approach we will go with. And for this, we can actually go with either breadth first search or depth first search. But I'm thinking I will go with the depth first search just for simplicity, since I want to go by, I just want to compare each of them if they are similar. So any of them could actually work, because if I use the breadth first search and I put them inside a queue, then if they are the same, if I have 2 queues for both of them, then the same value should be at the same point. For example, at the beginning we have the root node, and then subsequently we have maybe 2 and 3. So at every point there should be the same value when we pop. So when we dequeue this and we dequeue this, they should always give us the same value. So breadth first search could work, but I'll go with depth first search just because I want to use recursion, because I will not need to be thinking of creating the stack manually. So that's just why I'll go with the depth first search. So let's get to LeetCode and see how we can put this down. So we are basically just checking if our left, or if a node is the same, if the node at P is the same as the node at Q. So let me just have my function here, my depth first search function. So let me just call it, okay, and we have to return is a boolean. So let's say is same
3 DFS. So I will expect, yes, I think I should expect the 2 nodes. Okay, so what basically I want to do is I want to check if so if at any point, so for example, if I go back to the board, if at any point, for example here, when we wanted to check for this, we saw that the value, there was no node here because there was is null. So if at any point when I'm checking I get either of them is null, it means that it's not going to be symmetrical. It means it's not identical. So that's the first check I want to put there. So if P is null or Q is null, then I want to return false, because definitely it means it's not structurally the same. But you know, it's possible that both of them are null now. So for example, if we come here, when we, you know, for 2 now, when we check the child of 2, it is definitely null, and the child for this 2 is also null. So if both of them are null, it means that's fine. Okay, so what I will now do, so I want to put that before this, because the or, if I do it before that, it will, my logic will not make sense anymore. So return true. So if I put this logic before this, because it means that it will never have it to come here, because this is going to always be true, because if both of them are null, then it means that P is null or Q is null will always be true in that case. So I have to first of all check for this. So I think I can even use an else if, since these two situations I don't expect them to occur at the same time. Okay, so then finally I want to check the data within them. So for example, I want to check the value between p.val. I want to check if it's the same with the value in q.val. So if these values are not the same, then I know definitely it's not, then there's no point, it's actually false. So let me just call it check. Let me call it check. So if they are the same, then I know that it's possible that it's fine. But what I want to now do is, after checking for this, I want to check. So basically, okay, so I want to return, I want to check for this, but I also want to do the same thing for the left child and the right child. So I will just send for the left, I want to compare the left of the P with the left of the Q, and I also want to do the same thing for the right. Yes, so I will check for the left and I also check for the right. So that's basically what I want to do here. So P dot, okay, so this is going to be for right, and then Q dot right. So basically what I'm saying is that if either this is, if this is true, then that's fine. But if this is not, if we see that our P dot value is not the same as Q value, then we know definitely it's going to be false. Then it will not even go bother running all of this, because it has found this to be false. But if this is true, it then goes on to check for these two, for the two children, the left and the child, and left and right child, basically. So I think this should, so basically here, since this returns a bool, so I just should return is same 3 DFS, and then I pass in P and Q, and I think we are good, because even if P and Q are null, we are making sure we are checking for a situation where if both of them are null, or if one of them is null, we're already taking care of that. So we know definitely here that P and Q, none of them is null. So I think this is fine. Let's run this and see. This looks like a pretty straightforward algorithm with a pretty straightforward solution. So I don't think we'll be delaying on this video, but let's see. Okay, so and that passes, and that's actually the solution. So basically you just see that what we are doing is we are checking the node, the current node we are checking the current node where we are, if the values are the same, and then we're now checking the children node on the left and the children node on the right to see that they are the same. So how do we know they are the same? We know they are the same if both of them at a point, if the children node, for example these two, for example the child node is null, and this one's child node on the left is also null, on the right this is null and this is null. So it knows that that is true, and then it now checks that the value here is 2 and the value here is 2. So that is that it checks this value, and then it does for the left and it does for the right. And if for any reason we have a place where, for example, we have an extra node here, and this maybe is 4 here, this doesn't have a false, so definitely it means that if P is not null, Q was null. So you will see that this is the condition that we run, and then it returns a false. And if that is false, it just blocks every other thing, because if this is false, it doesn't even bother running all of this. So that is how we come up with this solution. I hope this was pretty clear. If we still need more explanation, or we have any question, we need clarification, please drop in the comment section, and I'll try to address that, or maybe respond to the comment also, whichever will be appropriate. Thank you, and see you in the next video.